On the screen you have a mechanical system here, and our objective today is to be able to generate a bond graph model from it. So what I want to show you are the steps that you need to follow systematically so that you can generate that bond graph in an easy way and with no errors. So let's take a look at the system in here and recognize what we have in here. I think one way to do this is we could even build the bond graph right on the system. Yeah, it might not be a bad idea to do that, so that we can see the relationship of the physical system to the bond graph model itself. So let's just begin over here, and I am going to put the what I call steps, steps to generate the bond graph. Okay, steps. Okay, the very first step is one, I would say, use a one junction for each distinct velocity. I would say including the reference or the wall in this case to make it easy. So what I would do is I am going to use a red pen so that I indicate the velocity here. This is a 1 for x1 dot, let's say the velocity of this one. I'm going to put a 1 for x2 dot, which is the velocity of the other mass. And to make life easier, I think I am going to use a 1 for the velocity of the wall, which is equal 0. And equally on the other side, I will put a 1 for the velocity, let's see, 1 velocity of the wall equal to 0. Very good. Step number 2 you're going to do is you will say attach, attach the elements that experience those velocities. This includes sources and other elements. Like in this case, I would attach a source of flow with the velocity of the wall equals to 0. Okay. I would say that on this one right here, we have the I element over here with value m2. This one, you have the I element with value m1. And in here, we will put the source of flow with value of velocity of the wall equals to 0. Okay. So, do we have any other elements that attach to these one junctions? The answer is no. So I am going to go to the next step, number 3, which would be use a 0 junction. Okay. To represent the velocity differences. Okay, so in this case we have the velocity differences here. What do I mean with that? Hold on for a second. You have this velocity differences in between this and the wall. There's obviously this element. See the difference between this. Between these two elements, see the difference. Between these two, this one sees the difference. So what I'm trying to say is, let's build this zero junction that says, let's adopt the convention that we're going to the right. This would be this velocity minus this other one. This is in fact velocity x sub 2 minus velocity of the wall. That's what it means. Let's create this one too. Alright, the velocity of this is x1 dot minus x2 dot. Okay, and let's continue over here. This is 0. I'm gonna put it in this direction because the 0 is on the left hand side, and x1 is bigger. So this one I would say is x sub 1 minus velocity of the wall. That's what this is. Okay, then step number 4, I am going to say attach the elements that experience those velocity differences. All right, those velocity differences. And so in this case, let's go first to the one over here, right here. We attach that one that sees, what does this one see? The C element with value k sub 3, 1 over k sub 3, yeah. And then we have this, you have the damper as well as you have the spring. So you have the damper, which is R with value fb sub 3, and then you have the C element, the C element which has the value 1 over k sub 2. Okay, the other thing is this one here. It has the element which is C with value 1 over k sub 1, and I think this basically allows us to complete the bond graph model, except that there's one thing that I'm noticing right now. Do you see this element over here, this one, and then this one? It talks about the friction between these two. So that friction is over here, see, because this is the reference 0. So this would be an R element with value fb sub 2, and on this other one would be an R element with value FB sub 1. As far as I'm concerned, this bond graph model is good enough to put it into the CAMG software because it has enough information that is for the software to number the bonds, and it has enough information to continue with the with the simulation. CAMG will do the causal assignments, but in this particular case, we are basically finished with that. In here, I'm gonna say you don't even need to simplify it. I think that you could leave it like this and do your simulation. In fact, I would prefer you do that to make your life easier. But if you care, you could reduce this. So, but in here you could say complete the causal marks and number the bonds. You do that for reference. You do that so that you can actually do that. The last thing I'm going to do is to assign that causal mark and be done with this stuff. So I am going to use a blue pen in here. How do you assign the causal marks? First, you assign it to the sources. So this has to be like this because these are flow sources. And the moment you do that to a one junction, this has to be like this. And the same thing over here, see? Then the next step is to put the I element in integral form. That sets the flow to this one and makes this two like this. And I do the same thing to this one and makes this two like this. Yeah? And then we gotta see what the consequences of that assignment is. You see in here you have this two flows into the zero. The zero needs one effort, so it's gotta be like this. And the moment you set that, it makes this one like this. And then over here you see you have all the ones. This is sorry, I didn't assign it to this one. When you do the one, it makes all the others like this. And then you have this two, the zero needs one like this. The moment you set that one, makes this other two like this. And finally on this side you have the two flows in, maybe zero needs to be like this, and that makes this, and that completes the entire bond graph model. We have drawn it right on the system, and to indicate that this one junction, this element corresponds to this mass, this, and this friction corresponds to this, that this element corresponds to this, and the wall. So there's a direct correspondence between the physical system and your bond graph.